Hi. So in this session I want to write code for finding the first index in a list, right? Okay, so first index, you are given a list and you are given x that you need to find. Let's find the length of a, and in this particular function I'm going to make a copy. Then I'll write another function in which I'll not be making a copy of the array of the list. Instead I'll be using the start index, and I keep saying this array and list. I hope you understand we are using lists, but I keep saying array every now and then because in every other language we use arrays as the default name. Okay, so I have the length. In case the length is 0, that means the array is empty. I think I need to return -1. If array is empty, there is no way I can find x. That basically means I need to return -1. Now that you have checked the array is not empty, it has at least one element, you can check if a of 0 equal x, right? So I need to check the 0th element. If this itself is x, then I don't have to do anything else, I can just return 0. And if I have crossed this if, that basically means you don't have an x here, you don't have value x here, so you need to make a call on the smaller part. So let's create the smaller array by using slicing, and smaller list output you can calculate by using the same function. It's a smaller list, so induction hypothesis say that you can use the same function on this, and you need to pass x, so you get the smaller list output. So the smaller list has given you a number, I'm calling it k, here we are saying smaller list output. Now you need to check if k is equal to -1. If k is -1, that means smaller list is saying, hey, I couldn't find x anywhere. That means x is not here. X is also not here. That means x is not present in the list, and we should return -1 itself. So let's make a condition. If k is equal to if smaller list output is equal to -1, I need to return -1. Else, if it's not -1, that means you have found x somewhere. Let's say we found the x at location 3, index 3. The index 3 is specific to the smaller list. It's with respect to the smaller list. That means you need to return this +1, because you have another element in front which you have not accounted for, so you need to account for that as well, and the index in the total list becomes smaller list output +1. Okay, before we run this, let's see how this is working. So let's say this is my input and I'm searching for 7. Okay, I'll take two examples, in one in which you have 7, in one which you don't have 7. Let me put another 7 here. Let's say this is my array. Okay, so I need to find 7 here. Perfect. What is the length? Length is 7. Okay, let me take another example. I don't want the length to be 7. Let the length is 8. Okay, too many 7s will become confusing. So you have 8 elements. 8 is not 0, so you come here. This is not 7, so you come here. You make another list, smaller list, which is a copy 3, 5, 7, 9, 7, 10, 11, and you call the same function on this. So you want to find 7 in this one. You again go there, the length is still not 0, the 0th element is still not 7, so you make another copy and you ask it to find 7. Length is still not 0, you don't have 7 here yet, so you basically make another copy and you ask it to find 7. Length is not 0 yet, but you have a 7 at the beginning. So this list is going to return, hey, I have found 7 at 0 index itself. Now this list here, this function here will say, hey, you haven't returned -1, that means you found something, and because you found something, I'm going to add +1 in it, so it's returning 1. That means it's saying, hey, I have 7 at index 1, which is correct. Then this is going to say, hey, I have 7 at index 2, and this is going to say, hey, I have 7 at index 3, and it works fine. Let's take another example. Let's find 7 in this. So length is not 0, 0th element is not 7, so we make a copy, we call here, again, length is not 0, 0th element is not 7, so we make a copy and we try to find 7 in this. Length is not 0, 0th element is not 7, so you make another call. Length is not 0, first element is not 7, you make another call. 11, 7. Length is not 0, it's still 1, the 0th element is not 7, so you make another call to an empty list. As soon as you reach an empty list, you return -1. So this returns -1. Now this list here says, oh, my small list output is -1, so I need to return -1 as well. This will say, hey, I got -1, so you're going to get a -1 as well. You're going to get a -1 as well. You're going to get a -1 as well. And you're going to get a -1 as well. And my function will return -1, which is the correct output. Okay? Which is the correct output. Perfect. So let's print first index of 7. First index is not defined, we didn't run this cell. Let's run this now. It's saying 5, which is correct. 0, 1, 2, 3, 4, 5. Index 5 is where 7 is. Okay, so it's working fine. So let me quickly make a copy of this, and this time I'm not going to make, okay, let's not make a copy, let's write the function again. And we don't want to make a copy of the list given to us. We don't want to do this. We want to use the same list by using start index. Okay. First index better, A, X, and start index. Okay. Let me find the length. Now you have this list and you're given a start index. What should be the base case? The base case will be when I don't have anything to do work with. There is no elements left. That means my start index is here. That means start index equal length. So if it is equal to L minus 1, that means there is only one element left. If it is equal to L, that means you have crossed. There is nothing left. Okay, so my base case is SI equal L. That basically means the start index is pointing towards no element, there is nothing left, I can't do any more work. So that means I can't find X anywhere. That means I'm going to return -1. That's the same as this one, but this time because the list is not reducing in size, list L is not going to go to 0, but the start index is going to go towards L. Okay, so if that means I can return -1. Okay, what to do now? Okay, so this is my array, this is the start index, and there are some elements left, because if there was no element left I would have returned -1 from here itself. So now I need to check at the first element, the 0th element, which is not at 0, which is at SI. So I'm going to check if a of si equal x. In this case, I'm going to return. Now I'm not going to return 0. There is no point returning 0. Now I know this is a bigger list, and I know the exact index where I have found x. So I am going to return si itself because I have found x at si. Now let's call the smaller. We don't have to create the smaller list. We just need to call on this list itself first index better. The same list, same x, but si will be increased by 1 because this is the case when you could not find x at si. We don't have x here. So we are making a call on this part. Okay, we're making a call on the smaller part. Now, whatever the smaller part returns, if it returns -1, I want to return -1. If it says that, hey, I have at index 9, then the index 9 is not in the smaller part, it's in the actual list. So I can just return that as it is. Okay, I can return it as it is. Let's take an example. So let's find 7 in this. So what's going to happen? Start index will be 0. You will say, I don't have a 7 here, so we'll call start index 1, not 7 here. Start index 2, we don't have a 7 here. Start index 3. With start index 3, you will find 7 there and you will return 3. So you will get a 3 from here. Now you don't want to add 1 into it because in the original list you have 7 at index 3. So you don't have to do +1 the way we were doing it here. Okay, because we are not making a copy. So you get the smaller list output, and guess what? You don't have to do anything. You can just return the same. And let's see if both these return the same value. First index better, a comma 7 comma 0, which is the start index, and yes, both of them returning the same thing. You have seen the solution, but please write this code by yourself, because unless you do that, you will not really understand how things are working. Okay, thank you.